So I'm going to walk you through an application called HighQA. HighQA is a quality management system that manages more effectively processes like FAI, PPAP, APQP, ISIRs and the like. So what I'm going to do is do a quick demonstration on how effective we can extract information from 2D drawings and convert it into digital data. So this is HighQA. I'm going to go and select a particular drawing. When I select it, I'm going to just double click, and what you'll see now, this will open up the drawing. And on a drawing you typically have lots of general tolerance dimensions, you have lots of geometric symbols. We use OCR. So OCR is the facility to actually interpret all the information and convert it into digital data. So what we can do now is I'm just going to rotate that and orientate it in the right orientation. And what we're going to do is use optical character recognition. So that is the AI within the system, and I'm just going to select OK. So what this is going to do now in a few seconds is interpret all of that GD&T, general tolerance dimensions, into our report. Okay, so what you can see now, the OCR has actually interpreted all the information, and I'm just going to maximize that and say fit it to the screen. So you can see now every particular feature on the drawing has been captured. We can also use whiteout to make sure we've not missed anything, which is obviously important. We can also, it will see how it's interpreted the information. So you've got your bill of characteristics. We can expand that to physically see everything that it's interpreted. So now this is all our general tolerance dimensions, all interpreted. The idea of this is if we want to create our report in HighQA, you can create any kind of inspection plan. And again, whether it's an FAI, whether it's a PPAP dimensional. It comes with its own report designer. But the idea now is if I want to see a particular report, whether it's AS9102 and we're currently at Rev C or Rev D, the idea now is it's going to generate that report. So it's saving engineers all of that time to balloon, create the report, and as you'll see now, all that information is extracted. It doesn't just focus on Form 3, which is your dimensional. AS9102 is your first article process, and that is actually Form 1. Form 2 is any materials and processes you've used, and Form 3 is all of your dimensional information. So if we think about it, that is a very quick return on investment for anybody that's doing FAIs, because that bit takes such a long time. That's now going to save all that time on the preparation side of it for ballooning drawings. And later on we're going to cover how we can collect data and explain how we collect data from CMMs or VMMs, also how we collect data from the shop floor, and also how we can manage a whole APQP or PPAP process. Okay, so now we're going to discuss interrogation of data from any kind of CMM or VMM types. We've actually got a MicroView Vertex 261 here that we're actually going to use in this example. So what I've got here is actually a balloon drawing that we ballooned within HighQA. And what we've done is we've programmed that in line with the actual machine itself. So what we've got is a little bit of a routine. If I go to here, and I'm actually just going to run this, when I run it, it's asking for a serial number. So this is where you can then serialize parts. So I'm just going to give it a serial number. Straight away, it's now going to run the machine and it's going to do the program. The program then will have all those identifiers where we've linked the balloon drawing to the actual program, and then that allows us then to analyze the data, whether it's from an SBC standpoint or just physically, whether it's just a single component level. So that's going to go and do its programming. It's a multi-sensing CMM, so again it's got a combination of touch probe as well, so that allows us to go and do all the internals. So if we just bear with that a few minutes, that allows us to go and then absorb the data. There you go, the program's now finished. So what I'm going to do now is I'm going to go into the HighQA software. So obviously, as I said, we've done all the ballooning. We now want to actually see the data. So the data has been grabbed basically by the file output on the machine, and we can go into here and we can go and select the data. Oops. So here is the results. So we've now got results displayed as whether they're in tolerance as green. In red are obviously showing non-conforming features. and the violet or purple colour is actually demonstrating features where there's a variation between the CMM program and the tolerance and the actual tolerance that's been defined on the balloon drawing. So now we've got traceability now of all the data and any kind of variation. If I want to then go and create my FAI, so whether this is a first article, a PPAP dimensional, whether it's actually an ISIR form, all those forms can be customized however you want them to be customized, even to meet your customers or internal requirements. But what you'll see now, this is actually going to generate a specific AS 9102 Aerospace Form 3, and in that Form 3 will be all the data. So here we have it, all the data. So again, just to reiterate, we ballooned the drawing more efficiently and effectively. We've captured all nominals, tolerances, grid lines, and now we've even absorbed the data from an example of this microview machine, and it's demonstrating whether the features are in or out of tolerance, again with colour coding, conditional formatting within the forms. Okay, so we're going to demonstrate the HighQA shop floor applications, Inspection Manager Explorer and Express. Just a browser application, very simple. The idea is you balloon your drawings in HighQA, and then you can use the shop floor application as a method of only displaying features that inspectors have to measure. Very simply, I have a vernier that's Bluetooth. I just simply click the button. If it's in tolerance, it identifies it as green and it shows you that it's in tolerance. If I go and click the button again for the next feature, if it's out of tolerance, straight away it's going to inform the user, do you want to measure again, or do you want to actually raise a non-conformance report and keep it failed? So again, to measure again, you just select measure again, and all you do then is go and collate the data, and it will obviously give that result. The advantage of this is we can also manage calibration of gauges, so it means we'll know whether the gauges that we select are actually calibrated or not. So again, very useful application, very easy to use, very intuitive. HighQA also have a module to manage the APQP process. So if we think about businesses that manage their APQP process, it's very time consuming, very laborious, and it's typically managed in Excel. So I'm going to demonstrate an application now that manages that as a process. So the PQP module is the application to manage the APQP process. It all starts from the balloon drawing. So you'll have all your features dimensioned. In here, you will select the manufacturing operations. Each defined manufacturing operation is then filterable, so you can go and select what features are measured at which operation. But when we think about process flow, FMEA, control plan, etc., all of those process steps are already defined within Inspection Manager. So as we select the module, you'll see now we have all of these defined instances. So the APQP process will be a list of elements within a business that you specifically follow. And again, as I mentioned, it's done in Excel. What this module does is allows you to define all those instances. Behind that, you'll have a document based around AS9145. So for example, you'll have a balloon drawing. We've already ballooned it. We'll have process flow. Again, if you think about it, you do it in Excel. What this has done is now hard-coded it, and it means the process step that we defined in Inspection Manager has pulled through all of the defined process flow elements. Behind each element, you will have a workflow. Again, fully customizable. It will also give you who's responsible and at what time they need to go and make any changes or an amendments to it. So again, we can define a workflow. The concept then is, as we're building the process and we're finishing each particular element, you will define these at 100% complete. Then when you go and create a package, it's going to be the finished PDF with everything that you've included within those elements. So you'll have potentially your cover sheet, you will have maybe your balloon drawing, then you will have your process flow, your FMEA, and so on. So the idea is, instead of working with lots of different Excel spreadsheets, it's the ability to manage each particular element of that particular process specifically link back to the balloon drawing that you started right from within HighQA from the ballooning. Okay, so that's the overview of the HighQA application across various modules. I'd like to open this up to questions. Thank you.